Dear students, greetings and welcome to the graphics class. Today we are going to discuss the 10th problem of sections of solid. Just I will read the question. A cone of base diameter 60 mm standing upright is cut by a section plane such that the true shape is a parabola of maximum double ordinate 50 mm and vertex of the parabola is 50 mm from this ordinate. Draw front and top views and true shape of the section. What is the inclination of the section? The question is related to a cone. The cone is resting on HP such that the axis is perpendicular to HP and it is resting on its base. There is a section which is cutting the solid such that it is providing you a parabola. There are some difficulties related to this particular problem. Just like in the last problem, here also the complete details of the solid is not given. The diameter of the base is given, but the height is not given. Here there is a parabola. The size of the parabola is mentioned like the double ordinate is 50 mm and also the distance from vertex to the ordinate, that is also 50 mm. So such a section we are getting. Now we will try to find out how we will get the sections from a particular cone. That is the first step we will discuss. After that we will go to solve the problem. I will draw the front view of a cone. Here you can see that these two are the generators and this is the base. Consider a section which is, okay, this is the axis of the cone. Now I am going to cut the solid such that it is cutting all the generators. You can have any number of generators. I have drawn only two, but you can have any number of generators. I am having a section plane which is cutting all the generators perpendicular to the axis. Then normally we will get a circle as the section. The section will be a circle. Now you consider another situation. Here there is a cone. This is the front view of the cone. This is the axis. I am going to cut the cone such that the section plane is inclined to the axis and it is cutting all its generators. Now you can see that the obtained section will be an ellipse. It will be an ellipse. Ellipse. Consider another cone, the front view of another cone. Here, again this is the axis. You are having a section which is parallel to one of its generators. Parallel to one of its generators. So normally this will give you a section which should be a parabola. It is easy to remember that the section plane is parallel to one of its generators. So the obtained section is a parabola. So now we will discuss about the parabola. For any parabola, this is known as the vertex. This is the vertex of the parabola. Vertex of the parabola. And this is the abscissa, or this is the distance from vertex to the double ordinate. Say, let this be AB. So AB is known as the double ordinate. Double ordinate. The distance from vertex to double ordinate is known as abscissa. In the question it is given that the distance from vertex to abscissa is 50 and AB is also 50. We will discuss this once again. Anyway, for getting some idea, I am giving this particular part. So, this is the parabola which you are getting. Now, along with this, I have to tell one more thing that I will show here. That is, one more section is possible. Already you have drawn such a situation. That is, you can have a section plane which is parallel to the axis and it is cutting a part of the generators. The section obtained will be a hyperbola. The section obtained will be a hyperbola. So, in this particular problem, we are much concerned about this part. That is, the section obtained is a parabola. So, the section plane should be parallel to the generator. According to the problem given, there is a parabola as the section where 50 mm is the double ordinate and 50 mm is the distance from the vertex. Now, what is the relevance of this section with the given problem that we will discuss now? In the question, it is given about the diameter of the cone. The diameter of the cone. Now, as usual, if you are having the top view as a circle, normally we will divide that circle into any number of equal parts. Let it be 8 parts. So, this is O comma O1, A, B, C, D, E, F, G and H. Then we will draw the front view. But the front view, we can have or you can show only the axis. You don't know the height of the axis or length of the axis. Then how to do this? We can complete the base, that is A dash, H dash, B dash, G dash, C dash, and here you will get F dash, D dash, and finally you will have E dash. Now, the diameter is actually 70 mm. It is given. It is given that the double ordinate is 50 mm. That means the double ordinate should come exactly here. Up to this, there will be the section. So, you can measure 50 mm parallel to this line, perpendicular to this line, and you will get the double ordinate here. The double ordinate and the remaining part can be considered to be the section obtained in the top view. The section obtained in the top view. Just like in the last problem, you can have one dimension in the top view, that is the length of the double ordinate. Now, we don't know the height. Then how to solve this? We can have before drawing the front view, again I am showing you the front view of the cone. If you have a parabola as a section, there should be a section which should be parallel to the generator. So now you look here, you can see that this is an isosceles triangle. These two sides are equal. So there is an isosceles triangle. Then only you can find out that this is the section of the chord. So what should be the length of that section? The length of that section should be exactly the distance from vertex to the base or double ordinate. The distance from vertex to the double ordinate. So 50 should be one side. Now we can do one thing. See, already we have got, see, A dash as one point. Let this be A dash. And you are having, see, here you can have, assume that this can be, or you can have 1, 2, 3, 4, 5, 6 and 7. So you are having this as 4 dash comma 5 dash. So this point is 4 dash comma 5 dash. So if this is 50, this one also should be 50. So from A dash, taking A dash as center and 50 mm as radius, you can draw an arc. Similarly, from 4 dash 5 dash as radius and 50 mm as radius, you can draw the next arc. So now you will get a line connecting A dash to this point and another line to 4 dash 5 dash. 4 dash 5 dash. Okay, now we got only this part. The remaining part we have to complete. So one important thing is, already you are having an inclination here. The same inclination you got. So if you extend this line, that will intersect with the axis. That will intersect with the axis. That point already you have got, that is the vertex. So that may be O dash. That may be O dash. Now from O dash to E dash, you can draw another line. So that is the next generator. That is the next generator. So now what you obtained? You obtained the section like this. This is the section which you obtained. Already you are having the section, and parallel to that you are having the generator. So the final section you are obtaining as a parabola. So before going to draw the parabola or the final parabola, we have to draw the remaining part of the front view. You can connect O dash, H dash B dash, O dash and G dash C dash, then O dash to F dash D dash, and the final part is O dash to E dash. Now we can draw the true shape. Before going to the true shape, you have to mark the points also. So this is 1, this is 2, 3, this is 4 dash, 1 dash, 2 dash, 3 dash, 4 dash already there. Again there is 5 dash, because at the base there will be one portion at the front and one portion at the rear part. That is 5 dash. Then you are having 6 dash, 7 dash. So all the 7 points which already we have marked in the top view, you are getting here. Now we can do one thing. We can have another line which is parallel to the section plane. Parallel to the section plane. Not a plane, it is actually it is actually a plane, no, not a line, it is actually a plane. So now you have to draw perpendicular lines from 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. From all the points you have drawn that. Now what you have to do? You have to take the distance from xy to 1. You can measure this distance and you can mark it here. So this corresponds to 1 double dash. Now from xy to 2, the next point you will get, that is 2 double dash. xy to 3, that distance you can take, and this is 3 double dash. xy to 4, that you will get, that will be here. xy to 4, that is 4 double dash. Now xy to 5, that you will get 5 double dash. xy to 6 you will get 6 double dash. Then you will get 7 double dash. All the points you have got. Now you can join a smooth curve connecting all these points. You can have a closed curve, a smooth curve connecting all these points. You can close this contour, then you can hatch it. So now you got a parabola which is of double ordinate 50 and the length from vertex to the double ordinate as 50. This is what asked in the question. So before concluding, first we have found out the actual section. The actual section is a parabola with double ordinate 50 and the distance from vertex to double ordinate as 50. Using this, we have found out that there is an isosceles triangle formed as a part of the front view. That isosceles triangle we have found 50 mm as the length. Now we have drawn the top view. From the top view, you got 4 dash 5 dash such that that distance is taken as the double ordinate 50. Then we have completed the section in the top view and we have hatched it. Then you have drawn all the points here. Then you have drawn the isosceles triangle by drawing 2 arcs. Then you have completed the generator by extending from 1 dash to O dash. Thus you have completed the front view. Using the points on the top view, you have drawn the true shape of the section. This is what we have done. So compared to the last problem, this one is also exactly similar to that one. Only thing is you have got a parabola as a section. That is the only difference between the last problem and this one. By this we are concluding the sections of solids. We have drawn 10 figures, out of which 8 figures are related to the sections. The remaining 2 are related to the true shape of the section. The last 2 problems which we have done are of the same nature. Now you can complete these 2 problems as an assignment and submit it before 31st. Thank you very much.